So hello, today I will talk about the device side of our project. We utilize Photon 2 and we utilize the Max 30102 sensor in this portion. So I utilize the particles VS Code add-on to write this code. We utilize the state machine. I define the state as idle, request, measurement, send, wait, save to EEPROM and empty based on the actions that we are doing. So those are the default parameters like 30 minutes wait, 5 minutes timeout, from 6 to 10. But all of those can be modified using our website interface. So let me start with the setup code. So in here we are setting our pins and the sensor using the Max 30105 library. So those parameters. I tried multiple of them. I tried different variations, and these are the final parameters that we are using. And in the loop code, this is running always. We are retrieving the sensor data using sensor available. We are checking, and we are getting each sample. So in here, after many trials, we determine the best timing for clear and less noisy data is we are using a buffer size, which is sampling time times sampling frequency. And after our trials, we determined the 4 seconds as the best sampling time and the 50 hertz for the sampling frequency, which gives us the clear, less noisy, and as accurate as possible. So we are getting those data and printing out here, but our state machine actually works here. So we have this switch case to determine which state are we in. There's a request measurement state, which we are asking data from the user. And all those timeouts are for the changing the states. There is a send state, which we are sending the data. So if I go to send state, we utilize 2 different methods to send the data. There's one, if you use the particle itself. So there is particle interface, which I utilize to send the data to our server. I first send the particle, then from there I utilize webhook to send it. But there is another way to do it. If we directly send the post request to our server, we were able to do that, and we have the API key here. We are also checking the response. So there is also the EEPROM side, which, let's say we don't have the internet connection. What we are doing actually, we are going to the EEPROM state, and we are saving those data to EEPROM. And we can save multiple. You don't have to save just the last one. And we are checking for 24 hours before. So those data can be stored only for 24 hours, and it will be reset after 24 hours. Apart from that, we utilize the config from the server function. So we are reading the data from the user's device. So we are actually reading the device ID that's on the particle, and we are getting the measurement interval and start and end times, and we are updating those based on the things on the server.
In this portion of the recording, I will go over user registration, login, and account logic. So first of all, as you are following the Express setup, we have some folders here. So public has the front end and the Ajax requests here. So first of all, I will talk about the HTML files for the front end. So here we have register.html file where basically users can create a new account, and we have some text fields such as email, password, and device ID. So we let users to um, register a device when they are registering their account. And then here we have login.html. Once the user creates an account, then they can basically enter their email and password and login. And we also have account.html here, and here we have multiple fields, so user can change their change their passwords, change the measurement settings for the frequency, and yeah. So these three files are the front-end files for the user. And then we have the three files for Ajax requests. So here for the register.js, we have a button in the register.html, which basically invokes this function, and it parses some email, password, device ID, and then sends an Ajax request as post to the backend so that users can be registered. And here login is something similar. Again, we get some data from the user, email, password, and then user sends the Ajax requests. We sent, like the middleware sent the Ajax request as the post for logging the user in. And then lastly, we have account.js, and this is actually a very populated file because here we are doing lots of stuff. So user can here change the password, change the measurement settings, add a new physician, and here we implement all those Ajax requests, and there are some post get requests. And then lastly, this is the backend folder, backend file for the where the requests are processed. So we have routes users.js here and here. For post requests, we follow we follow the same logic for each of them. We get some requests from the user, we get email, we get password, and then we basically process them and basically add that to create the necessary user in the backend, in the database for the register. And for the login, we check if the users are giving us the correct parameters, and then if we can um, and if they are giving us the correct arguments, then we are assuming that user is present, and then we log them in. And there are there's another get here, post here, so they can just change their passwords, and then they can update their measurement settings. So the setup is exactly the same, but the parameters and arguments change according to the request that we are getting from the user.
Hi, I will walk you through the implementation of GraphHTML, GraphJS, and the physician side of our IoT HardTrack project. Starting with the GraphHTML, we have utilized HTML, CSS, and JavaScript to construct a responsive user interface. We get libraries for charts, and we get Bootstrap for grid system structures, the layout with a sidebar, navigation, and the main content area. This ensures compatibility across different devices, and there is some basic code for styling. In GraphJS, we utilize chart.js for data visualization. The script uses Ajax to fetch sensor data from our Express.js backend and processes the JSON response and dynamically updates the charts in real time as users interact with the interface. When a user selects different devices or switches between weekly and daily view, the script listens for these inputs and fetches the relevant data via Ajax calls to our backend and refreshes the charts instantly. Shifting to the physician side, our backend is powered by Express.js and MongoDB. In Physicians.js, we have set up a RESTful APIs for physicians' registration, authentication, and managing patients. The physician model in Mongoose defines the schema, including fields like email, hash passwords, and references to their patients. On the front end, the registration form managed by Physicians Register.js captures email and password inputs, validates them in real time, and provides password strength feedback using CXCVBN.js. Upon successful registration, physicians are redirected to the login page. Similarly, the login form managed by Physician Login.js authenticates physicians by sending their credentials to the backend. Upon successful authentication, a JWT token is generated and stored in local storage, enabling secure access to their dashboard. Once logged in, physicians access the physician dashboard, where physician dashboard.js fetches all their assigned patients using Ajax. The dashboard displays their patients' heart health effectively.